All right. Well, I tried to put together the broadest overview of everything that we do, starting from the why to the all the way to the how and the nuances in between. So here we go. So just to start off, a quick snapshot of our program. So I'm the biological administrator for FWC's Aquatic Plant Management Program, and that encompasses public water bodies all across the state um, that are 465 lakes and rivers at the moment, which amounts to 1.26 million acres of surface water. And somewhere around 350 plus or minus 20 of those receive active management every single year. Every single one of those is surveyed by one of our biologists every year. All right, so like I said, before I get into what we actually do, I always like to go into the why we do what we do. So why manage plants? And this is the big reason. Biological invasions are the second greatest threat to biodiversity after land use change. So what that means is the only thing that causes more extinctions than biological invasions is when you destroy habitat. So pollution, climate change, overharvest, poaching, none of those cause more extinctions than biological invasions. In fact, 2 years ago, there was this big report that came out. Over 13,000 scientific studies and government reports from around the world went into making this assessment, and they found that invasive species have been a major driver in 60% of global animal and plant extinctions. And on islands, they were the main driver in 90% of extinctions. 1/6 of all extinctions had no other drivers except invasive species. Their habitat was fine. They weren't being overharvested. There wasn't a pollution issue. Any of the other issues that the our plants and animals out there face, none of that. It was just a biological invasion that displaced them and caused them to go extinct. So how does this cause such a huge impact when you take a species, take a plant, and you move it from one place on the earth and you drop it off of another place on earth? How can that cause so much harm? Well, I like to go back to this kind of foundational research where in the 40s and 50s, a lot of researchers were just looking at species of mammals or species of birds per land area or water area. And they go, how many species are there in an acre of land? What about 100? What about the entire county? What about the entire region? What about an entire country? And they found that it's extremely linear. And they go, okay, well, we can just extrapolate to the size of the earth and there should be this many species, right? And they're like, wait a second, there are actually this many species. Why is that? And the reason is because of isolation. Um, so the competitive exclusion principle says two species occupying the same exact niche cannot coexist indefinitely. One will drive the other to extinction. So a lot of people think, oh, when a new species shows up, that's extra biodiversity. It's another species. Great. But all species take up space and resources. So exotic species introductions aren't additive. One is going to displace the other over time. So if you were to push all the continents back together into Pangea, we would overnight, well, not overnight, eventually, we would lose more than half of our biodiversity just because there's no more isolation between those. Um, and unfortunately, humans moving species around, that breaks down those natural biogeographical barriers. It's like we're recreating Pangea because we're moving all of these species all over the world at a rate that is way higher than natural. And just an example of that is this fact in Hawaii, they dug up fossil records and found that before humans got there, insects showed up in Hawaii once every about 50,000 years. One insect species would show up there. Well, in the 20th century, 15 to 20 new insects established every single year. So that's an unprecedented rate of exchange that would not occur naturally. And so when you bring a plant or animal, today we're obviously talking about plants, when you bring them to a new range, they're leaving all of those things that are supported by that plant behind. So I like to use this little cartoon example. So the plant isn't supporting as many organisms. It's free to keep that energy for itself, spread out, take over area a lot more than it would otherwise. Whereas in an area in its natural range, it's got all these things that depend on it and all other things that depend on that food web. And in fact, I love this study where they did a meta-analysis on uh, all of these insects that are plant-eating insects and found that 91% of the world's plant-eating insects specialize to a single plant family. They can only eat from that one plant family. So there's a ton of specialization out in the world, and that's why um, it's so important to have the right plants in place because all of these organisms rely on certain interactions with certain plants. And I mean, that's a group like this, that's, kind of your bread and butter, right? Everybody knows, probably in this room, that if you want to have a monarch caterpillar, you have to have milkweed. There's nothing else they can eat, literally. If you want to have fritillaries, you have to have passion vines, so on and so forth. There's so many examples of this. And a lot of people go, well, who cares about bugs? But if you care about any other animal, you probably should, because 96% of North American terrestrial birds rear their young on insects, for example. And, most of those exclusively. They can't go to the bird feeder and grab some seeds and feed that to their young. They need insects. A lot of times it's caterpillars, in fact. And even larger animals like foxes and bears, a substantial proportion of their diet is insects. So if you want to have the insects, you have to have the right plants in place. Um, and if you want these animals, you need that base of the food web as well. So bottom line, when you take a plant and you move it around the world, all the things that it supports, all those herbivores and other organisms that rely on it get left behind. Less energy gets passed along to wildlife, and then it gets to have a competitive advantage over the native plants that are in that area. So it's not an even playing field when we are recreating Pangea, as it were, where we're just saying, well, one or the other is going to win out and it's 50-50. Well, actually, the invasive plant has an advantage because it shed all these other things that are holding it back, and it's able to keep that energy for itself. The first example that really sunk in for me was when I was studying in Sweden. We went on this um, 4-day long trip in the mountains for forest ecology, and we come across this one stand of lodgepole pine, and the professor says, "This pine's from Canada. They planted a bunch of it in the 70s because it grows faster." And I'm like, cool, this is a faster growing pine. End of story. Then, not too long later, I found a study from Canada where they said the native Swedish pine is such a fast growing pine and it grows so much faster than lodgepole pine. And I'm like, wait, so the Swedish pine grows faster in Canada and the Canadian pine grows faster in Sweden. And that's because they even quantified a lot of these things with the fungi that were missing from the native Swedish pine in Canada and the other species that rely on that tree as well, that it is not having to deal with in the exotic range. And we can see this pretty much with any invasive that we look at. Melaleuca, one of our worst invasive plants in Florida. 409 insect species feed on it in its native range, and it's actually a threatened plant in Australia. It's one of our worst invasive species. In the US, they've only ever found 8 species that can feed on it. Hydrilla, in its native range, they found 423 species. And you can see a picture of how it grows in a much different growing pattern often than what you see in the United States. Here, they found 15 species, and when you go out there, I can promise you, you're not going to find 15 species. Half of those are biocontrols we released that didn't really take, and other ones, you might find here and there, but you're definitely not finding 423 either. And this goes the other way. So our yellow water lily from Florida, this is about as thick as I've ever seen it grow. This is not the one with the white flower, it's the one with the smaller yellow flower. This is what it looks like when it grows in South Africa. That looks more like spatterdock than yellow water lily. When I did field work in South Africa, I saw all the invasive cactus and I always just assumed it was something from out west, but it's actually Opuntia stricta that is highly invasive in Africa and Australia. That's our Florida cactus. I mean, this is about as like strong as I ever see it growing out there. And here's a picture from the 50s in Australia where it's taking over the entire understory of the canopy. And there are so many things that eat it here. And in fact, they've taken like 5 of these species back to Australia and released them, and they're helping out a lot. The plant I studied for my master's is called Chromalina odorata. It's native to South Florida, all the way down through Central and South America. Here's a picture I took when I was in Colombia of it. This is very characteristic of how it is. Just, 2 or 3 stalks, just here or there, barely see it. Well, this is what it looks like in South Africa. It grows so thick that the only thing that can walk through it are elephants. Even giraffes and rhinos can't push through it. And in this picture, I'm holding a stalk of of a dead plant in an area that had just been treated, and you can see that most of everything that was there was that plant because it just forms such a thick, dense thicket, basically, of the plant, which is very different from how it grows in its native range. All right, so that's the background, why native plants are so important and different from invasives, and why invasives can be so destructive. So I'd like to just highlight a few of our top invasive species that we deal with on the aquatic side here in Florida, and how they got here and early management. So starting off, floating plants, this is water hyacinth and water lettuce. That report that I mentioned earlier actually recognized water hyacinth as the most widespread invasive species, plant or animal, in the entire world. So water hyacinth, it's native to the Amazon basin. It was introduced to the US in 1884. If you have the right conditions, it can double its population in 6 days. If you have okay conditions, 18 days, still very fast. And it forms dense mats that cover over the surface of lakes, crowd out emergent vegetation, shade out submersed vegetation, causes big problems. So we know exactly where this plant came from and how it got to Florida. In 1884, they had the World's Fair in New Orleans, and this woman from, I believe, Flagler County went to it, saw this plant, and was like, "That's really pretty. I want that for my pond." So she brought it back to Florida, put it in her pond. Well, it filled up her pond pretty quick. So she just took those extra plants and threw them into the St. Johns River. 10 years later, they were having big problems. And there weren't any highways back then. So they really needed the river for commerce and transportation and everything. Um, so it became such a big problem so fast that Congress established the River and Harbor Act of 1899. In that act, they put the Army Corps to work, and they were already using steam-powered barges to go and manually remove water hyacinth from the St. Johns River. And then, they did that for a while, and this plant kept spreading across the state. In 1958, they established another federal program that did a 50-50 cost share with the state, that expanded the work, broader than just the St. John's. So early control efforts were mostly mechanical. They also, before herbicide was really invented, they just sprayed arsenic on the plants, which was great. Um, and then, obviously that had so many problems. That wasn't a great solution. 2,4-D was invented, I think, in the late 50s or early 60s, and that really helped the state get things under control. You can see here in 1959, there were over 120,000 acres across the state of water hyacinth. And after a couple of decades of hard work, they got it down substantially. And by the 80s, they had it under control where we have statewide between 2 and 5,000 acres usually out there. But we still have a lot of problems. They grow so fast they can get past you really quick. You go out, everything's in good shape, and you come back and the lake is covered. You're like, what's going on? And yeah, I will get to water lettuce in a minute too. That's this picture here. Same types of issues with water lettuce. It can threaten structures. Here you see a bridge with a huge mat of water hyacinth heading straight towards it. Here's a bridge that's no longer standing because the same thing happened, but the mat of water hyacinth pushed it over and collapsed that bridge. So water lettuce, very similar behavior as water hyacinth. The origin of how it got to Florida is not as known as water hyacinth. It's native to the Caribbean, South America, and Asia. There have been we've been doing a lot of genetic work on this plant and found that there are multiple introductions to Florida. Even just in this area, there's population from Asia and then the Caribbean and one from the Argentina, Uruguay area of South America. Now, y'all have probably heard a lot of talk. I feel like a lot of people are really getting ahead of themselves with this one, but a lot of people are saying water lettuce is native now. Yeah, have y'all heard that? No? So, there was a core sample done on Lake Annie, and they found water lettuce seeds in that core sample from 10,000 years ago. Um, so that led people to say, well, it must be a native plant. And like I said, we've been doing a lot of genetic work. There is a biotype that is native to the Caribbean, and that does exist in Florida. So the thought is that that must be the same type that is likely to be native in Florida. But the one issue that I have with this that we're going to continue to look into is that there are over 30 specialist insects that have been identified for water lettuce, both in South America and in Asia. And if you were to really go look, most plants usually have 100 to 500 specialist insects that feed on them. And they've never found any in Florida, zero. The only insects that eat it are the ones that we've released as biocontrols. So either it went extinct and it was native here, or it's likely that there was another Pistia species that existed in Florida that dropped those seeds. Um, and a lot of people think, well, maybe there was a bottleneck and all those insects died, but the plant remained in different pockets around the state. But I find that one hard to believe. I think maybe it went extinct and got put back and is now no longer functionally native. But we're looking into it to see where that origin really is. We're doing genetic work from across the state. We're starting with 20 different systems all across the state. And the speculation from a lot of people doing this work is that the suspected native haplotype exists more in spring runs because maybe that was a stronghold during the Ice Age. And we're sampling 10 of those and 10 other systems. So far, we've only found that Caribbean haplotype that they had found in other areas in Florida previously in one of our sites, and that's here in the Wasissa River. Everywhere else has been from the Argentina, Uruguay area. And we haven't found that Asian one again that was found on the St. Mark's River a few years ago. So stay tuned with water lettuce. I should say these haplotypes are so distinct from each other that they might actually classify them as two distinct species. Whether one of them is actually native to Florida and the other is not, or they're both non-native, they're actually diverse enough to maybe be two species. All right. So our next big hitter is hydrilla. This is a submersed plant. Um, it can reproduce from fragmentation, tubers, turions, and seeds. However, in Florida, we have a dioecious type, male and female. We only have the female here in Florida, so it does not produce sexually here. Um, Almost 50% of fragments with a single row of leaves can sprout a new plant. This thing, you fragment it, I mean, it can root anywhere and it just takes over. Turions can survive ingestion by birds, and it can survive herbicide as well. So you spray that plant, the main plant dies, but it can still reseed. We know exactly where this one came from as well. In either 1950 or 1951, this aquarium dealer in Tampa had this stuff called Indian star vine. He grew it and he's like, I don't really like this. I don't know, it looks kind of dumb. I'm just going to throw it in the canal out back. He did that and then he went back out there a couple weeks later and he's like, wow, this thing's really taken off. And now here we go. We spend tens of millions of dollars combating it all over the state every single year just because of that one action that he took. It grows exponentially like most invasive plants. One of our colleagues at UF did an experiment where they took 10-foot tanks. They put a little 1-foot tall plant in it, and they said, how long is it going to take to reach the top of the 10-foot tank? 8 days. Then they did another one where they took a 9-inch shoot and they said, every time it branches, we're going to measure the tip of each one every day, because a lot of people say, oh, it grows so fast, it grows an inch a day. Well, they did that and they found that it grows, if you measure all the little tips that grow, it grows 191 inches per day from one single plant. This is all water, not a field. Just chock full from bottom all the way to the surface of hydrilla. It can cause the same structural impacts, and obviously you can imagine the ecological impacts that filling in your entire water column can cause. People will get tangled in it, drown often as well. So big societal safety issues with it. Here's a picture from here at Wakulla Springs where in the early 2000s, it got topped out, and then they did a drip treatment that got it under control, and it has been ever since. All right, so that was a little bit of the history. So like I said, we've got of our 465 lakes and rivers that are surveyed every year, we have about 350 of them that we have to do active management on. So I wanted to show you what that looks like. We have several regional biologists across the state that are in charge of a subset of our waterways. And here's an example of one of them. One of our biologists has Lake Okeechobee, which is huge. A lot of biologists have 50 or 60 lakes of their own, but this is like 50 lakes in one. It's 110,000 acres of marsh. But she also is in charge of all these other rivers and some of the lakes in the surrounding area. And we kind of split up the state depending on workload, and they're in charge of surveying and scheduling the work that needs to be done. And a lot goes into that. So they're constantly monitoring their water bodies. Like I said, all of those water bodies get an annual survey every year where they go and they estimate how much of the invasive species they have, and then they do a presence absence on native species. 50 of those water bodies have extensive plant mapping, which includes sonar mapping and what we call point intercept, which is a grid where you stop at every point along a grid. You throw down a rake and you see what plants are there. And then in the springtime, we try to look into the crystal ball and make a work plan for the upcoming year. This helps us budget, allocate resources, try to start making plans of what we think is going to happen. And of course, we have to stay on our toes because plants grow so fast in Florida that you can think, oh, I've got this under control. And then in 2 months, you didn't have it under control. And then we have to shift things around. But for the most part, we try to keep things tight enough to where we can budget for them. Then they go do their operations, and then the whole cycle starts again. They monitor how well that work and how everything's going, and around it goes. And there are a lot of challenges with plant management in Florida's waterways. We've highly regulated water, which changes the entire dynamic of our aquatic systems. Here you can see this hydro data from Lake Josephine, where the levels came up. You got a lot of floods and you got a lot of dry downs, and the water really fluctuated highly. And then they dammed it off, and now it barely fluctuates. We've got a lot more people coming to Florida year after year. So we have all these challenges with runoff and extra nutrients in our waterways and everything else that urbanization causes, and then other nutrient enrichment too, like agriculture. This is nothing you need to read, but this is from one paper where they talk about all the management considerations that go into aquatic plant management. And there's over 100 things on this list. Water uses and functions, control feasibility, the plants, the plant, like how the plant behaves, how susceptible it is to certain methods, and all these other considerations. So a lot goes into it. And we've got what we call our management toolbox a lot of different means of controlling plants. And one of the philosophies we implement as well is called integrated pest management. That's where we try to combine as many of these as possible in order to get the best control. So I'll go through some of these with, kind of their pros and cons. So the first one's kind of obvious, physical control. This is getting out there and pulling things by hand or using hand tools. Your advantages are, high precision accuracy, and you could be very thorough. If you have something that's a new species and you have a chance to eradicate it, like what we're going to do on the 24th, we've got Salvinia molesta at one spot on Lake Jackson. We can go out there, we can bag it all up with enough people and not have to worry about it again. It can be useful for that. Otherwise, it's very slow. You can't you could never keep up with the plants if you tried to do everything this way. It was one of the only options back in the day, but we have a lot more options these days. Cultural control, these are things like prescribed fire and drawdown. These aren't really control methods per se for invasive plants because a lot of invasive plants come from places that do burn regularly or do have a lot of water fluctuation. But it does help the health of the ecology of our natural areas to have a good fire regime or water fluctuation. So if you can increase the health of your area, you have more resistance to biological invasions. So drawdowns, we try to do them whenever we can. It's harder and harder and harder in Florida because people like to build their houses right around the lake and they get pissed when you draw it down, but also the people that receive that water in the next lake obviously don't want it to threaten flooding their home, so then they have to put that water somewhere. So the logistics of it are getting harder and harder. Fortunately, up here with like Lake Jackson, Miccosukee, we have lakes that naturally dry down on their own, and that really helps. But some of the advantages are oxidizing organic sediments. Without those floods that would historically occur, pushing those nutrients out, and when the water comes down, they stay out of the lake. They're all staying in the lake. So you have to get rid of those. So those can be oxidized. You can take them away with machinery. But that's also one of the big disadvantages is it's a huge operation if you're going to do all of that. And then again, the user groups don't always support doing a drawdown either. Here's an example on East Lake Toho and kind of what it looked like. They did a lot of work on the bottom to get some of that legacy sediment out of there and turn it to that sand bottom. Fire, yeah, we do burn on the water. You need a particular plants. Sometimes you don't always have the right fuel load and everything. This is another thing that's getting really difficult in Florida because of smoke management. There are some areas where, oh, you need this wind for it to be safe, but also it can't be exactly pointing in this direction because you're going to send it over the interstate or whatever the case might be. Um, but this is another way to stimulate increased diversity of plant communities and increase the health of the area. Mechanical control, this is things like mechanical harvesters that have this conveyor belt that bring plants up and dump them into the body of the machine, and then you bring it back and dump it somewhere. Shredders, which shred up mats of vegetation um, just to get them to fall to the bottom and not be consolidated. Dredges and other things. Um, this is mostly reserved for your big woody, what we call tussocks, which are these floating islands of vegetation. Um, it it's mostly advantageous there. Its disadvantages are that it's non-selective. So you have to have a mat where you want to get all of that. If you have native plants sprinkled in amongst invasive plants that you want to remove, you can't really use this because you're bulldozing everything. And you want to keep those native plants. One of the advantages is, though, you get nutrient removal if you're able to find a spot to bring that material out of the lake. If you use the shredder, it is going to stay in place. It's quite cost prohibitive. It costs a lot of money and it's pretty slow. It couldn't keep up with most invasive plants, but it does have its place, like I said. And here's an example of a harvester taking up plants, bringing it to the truck, and then the truck driving out and dumping it in a field. Here's an example where we definitely want to use it. This is the picture from before. If you were to spray this, it would take a very long time for that mat to break apart, and it would likely still push up against that bridge if the wrong wind blew, and it could really threaten that bridge. So we would want to bring either the shredder out or harvest those up. Other examples are like this, where one blows into a canal, blocks the whole canal, traps people in there where they can't get back through with their boat. They might have gone fishing that morning and come back to the canal being blocked like this. This is after the '04 hurricanes. All these huge trees are actually on a floating island. This is not rooted at all. And this was blowing all over Lake Pierce and, just ripping through areas of vegetation that we wanted to preserve. So they went out there and did a lot of mechanical work after that. All right, and then finally, chemical control. These are herbicides. Their advantages are selectivity, efficacy. They're very effective at killing the plants. You get a longer control period with them, and they're our most cost-effective tool. They do obviously carry negative public perception. I mean, they're chemicals. People have, you know, rightful skepticism towards chemicals. You can have visual impacts to native plants sometimes, which I'll show you. And the decaying vegetation remains in the system, unlike harvesting, where you're able to remove some of those nutrients if you're trying to get rid of the excess nutrients that you might have in your lake. The biggest advantage for herbicides is that they're selective. So here in this person's hand is a dying water hyacinth. You can see all these dead water hyacinth in amongst these very healthy native spatterdock pads because we used a selective herbicide that does not affect the spatterdock whatsoever, but the hyacinth is sensitive to it. So we try to utilize this scenario whenever we can. There's no silver bullet, but herbicides do allow for this situation to occur a lot. If you can't get that situation, you can still have selectivity, but you don't always get that beautiful visual impact. This is when they were using diquat. You had water hyacinth all in the spatter dock. They used diquat. You can see the diquat browned out all these leaves of the spatter dock. So people thought, oh, those are dead. You killed all the spatter dock. Well, all diquat actually does to the spatter dock is burn that leaf off, and the plant drops it, brings up another one, and after 3 weeks, everything's great and all the hyacinth is gone. All right, biological control. So this is what I was alluding to, with everything I went to in the beginning of the talk. There are insects that are specialists for all these plants. You can find the hyper specialist insects that only eat that one species of plant. Bring it back, test it, make sure that it doesn't eat anything that's native to Florida. And if it doesn't, you can release it and reunite that plant with some of its natural enemies, which helps control it. And there are all kinds of insects that do this, and that we've brought over here and released. Another type of biological control is a triploid grass carp. It's triploid, so it cannot reproduce. That way you can stock them at a particular rate. And I'll talk more about that in a second. One thing we don't do in Florida, but they do look into, I know they do it in Australia a little bit, and they're researching it in other areas, is plant pathogens. So when a plant gets moved across the world, it leaves behind 85% of the fungus species that it supports, and it leaves behind 25% of the viruses that would attack it. So if you can reunite the plant with some of those fungi, you would also have another thing to control it. And most fungi, as y'all know, are very specialist as well. So the advantages, obviously, for biological control from insects is that they're super selective. They can't eat anything else. They'll die. So you've got a super selective thing that reproduces on its own and can go after plants in areas that you can't get to. And you get long-term control from that. The disadvantages are that it takes 10 years or more from finding it to releasing it. It's a lot of work, a lot of money, a lot of investment. It's probably our biggest investment on our research side at FWC. And they're unpredictable results. They might do great in the lab, and then once you release it, there's something that's like, oh, yummy, yummy in my tummy. I'm going to eat that thing. And it's never going to eat a plant. So we've had very disappointing results in the past, but also some really good results. So it's an excellent option, something that we invest a lot in. Carp are really cool if you have the right scenario for them. They're from Asia. They're from where hydrilla is from, so we use it for hydrilla control. One of the disadvantages is that you can't use it for all of our invasive species, but they do highly prefer hydrilla. So, but the disadvantage is they will eat anything if they have to, and they can eat anything if they have to. So you stock them at a certain rate. They can't reproduce. You know exactly what the rate is. You know how many on average die every year. You can keep adding them, keep that rate, keep the pressure on the hydrilla while letting our native plants have some elbow room to grow and have a little bit of that competitive release. But the disadvantage is you can't stock them in a lake that has an outflow if there's no barrier. So not every lake has the opportunity to have these, because if you stock them at a certain rate to get control and half of them leave, well, you're not going to get that control. Here's an example where we had hydrilla take over this lake. So everything you see in red means that the hydrilla was growing from the bottom all the way to the top. So pretty much every bit of this lake was just covered. And they use herbicide again and again and again and again, year after year, and it just kept coming back. And other employees at FWC were saying, no, don't stock any carp. They're going to eat everything. It's going to be terrible. Well, finally they gave in. We stocked some carp, and this was the result. Exactly what you want to see. Open water, holes in the middle, surrounded by a mosaic of both topped out, sparse, and intermediate native vegetation in the lake. they put the pressure on the hydrilla, and the native plants were able to spread from there. Um, Here's all of our acres controlled over the years of hydrilla, put in the carp, barely had to do anything again, maybe treat a little bit at the boat ramp here and there. As long as we maintain those carp, they did all the work for us. All right, so here is our big management philosophy in aquatic plant management, and really, I guess, any invasive plant management. We call it proactive management. You may have heard of it also referenced as maintenance control. And the idea is pretty simple. Control populations when they're small before they become a problem and avoid crisis management. This is a picture of Lake Okeechobee. There was a herbicide moratorium in 1986. They quit controlling the invasive plants there, and then they had tons of areas growing like this. After 6 months, they rescinded it. It took years and years to get it back under control. And this is a picture of this guy that's going to have to go and spray all of this. And you can see, where are the native plants? Here, we've got little patches of these floating plants in amongst our cattail, bulrush, and other things that we want to leave. We don't want these to grow to the point where they're impacting those native plants and then spray them. We want to get after them before they impact those native plants. So we do still, like I said before, run into issues these days of crisis management. We don't get it right every time, but we strive for proactive management, treating it before it gets to this point. You can imagine how much work it takes to get all these floating plants back under control. Like I said, these plants grow on an exponential growth curve. Each one of these circles represents 42 days. So it's better to manage down here than up here. One really good example of this is in 2019, our program paused for 3 months. We didn't do any management at all. This is a graph from Okeechobee of floating vegetation. That's water lettuce and water hyacinth. And they generally on the Okeechobee consider if you have less than 500 lake wide, you're in maintenance control. You're doing good. We were there. We paused for 3 months. The plants exploded. We went back to work here, but it took us 3 years before we could keep it back under that line. 3 years of work for 3 months of pause. So it's really important that you keep your foot on the gas. And there's research to back this up as well. If you maintain lower plant levels, you will use less herbicide. They did this study where they took these tanks like this with water hyacinth in them, and they would have an original 10 plants, and they'd let the tank fill up 5%, spray that tank. Another tank would be allowed to go to 25, another 50, another 100. The one that was only allowed to go to 5% had to get sprayed 8 times over the course of the study. The one that got to 100% before they sprayed it, they only had to treat it twice. However, you can see how much herbicide total they used. Even though they went after this one 8 times, they used way less herbicide. It takes a lot more herbicide and work to go after an area after it's already spread through 100% of the system. Muck is also a big issue in aquatics, and people always talk about muck deposition. And a lot of times people say, well, I don't want you treating these plants because they're going to die and they're going to sink to the bottom, and that's going to create muck. Well, they found that you get less muck on the bottom if you actually treat the plants often. And the reason for that is because an actively growing plant like this one in this picture is always shedding leaves, especially one that's out in the full sun, like on a lake, and doesn't have anything else to eat it. So you already have a plant that doesn't have insects taking its energy, getting eaten. Maybe a bird eats that insect and goes and deposits those nutrients not in the lake. No, for an invasive plant that doesn't have very much eating it at all, it's just dead plant material that goes to the bottom. And like I said, most of these plants don't have the fungi that they do in their native range. So then you have fewer species that are there to break them down. So then you get even more muck deposit. So an actively growing invasive plant is just always shedding leaves, putting it on the bottom. So it's really disrupting that nutrient cycling as well. So one of our dilemmas, like I've already alluded to throughout this whole thing, is that, we want to control invasive plants before they become a problem. And a stakeholder will see us out there controlling plants, and they, in their mind, they're like, don't control that until it becomes a problem. I don't see the problem. There's barely anything out here. We want to control them before they're a problem. So the four takeaways of maintenance control, or proactive management, as we call it, is that if you stay on top of your management, you'll use less herbicide. That'll result in less spending, both herbicide and labor. You get less organic matter deposition, and obviously you have less impact on native plant species because you didn't let those invasives grow to a level where they're really impacting your native plants as much as they could. All right, so another concept, early detection, rapid response. This is what people call the invasion curve. You've got the time where you don't have any invasives at all, then the time that they arrive and they're kind of hanging out a little bit, and then there's that time where they just seem to be blowing up and spreading everywhere, and then they're pretty much everywhere once they get to the top of the curve. And what this one's showing is that if you prevent them from getting here, you get a huge return on your investment. Once they get here, if you go after them as hard as you can, you get a big return as well. Because if you let them spread everywhere, well, yeah, you're spending and it goes down a little bit and it pops right back up. And you spend more and it pops right back up. And, you're kind of spinning your wheels, but you're just kind of protecting, um, priority areas, more or less. So like I said in the history portion, hydrilla and water hyacinth were both traced back to single introductions. We spend um, nearly $20 million. Just my program, we're not the only ones out there treating these plants across the state. Almost $20 million a year just for those two plants that two people put out there. So we want to prevent the next one from coming along. And this is a really cool example of early detection and rapid response. And there's a lake in Central Florida called Saddleback Lake, where Agarria nahas showed up, or Nias, however you want to pronounce it. This we could not find another record of this ever being in Florida. So somebody sent some photos to us on September 21st of 2017. 5 days later, our biologist got out there, collected some, mailed it up here to our botanist. Our botanist confirmed which plant it was. Then they did surveys of all the surrounding areas to make sure there was that this plant was not in any of the other water bodies surrounding it. We sent it to UF and we said, can you test to see which herbicide will kill it? They confirmed it. Then they mapped the lake, and in under 3 months from finding it, they did all this work and treated it. And we've never had to speak about it since. A lot of people go, oh, well, why don't you just wait and see what happens, or see if it's a problem, or blah, 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 or this might be controversial if you go and treat this lake and kill this plant that you don't even know if it's bad or not. Well, we'll never have to find out. And also, this isn't a controversial plant because none of y'all have probably even heard of this plant because it's not in the US anymore. It's staying in Brazil where it's supposed to be, except that it's not because you can buy it on eBay. But, that's why we have to implement this early detection rapid response strategy, because when a plant pops up, you go after it and you get rid of that population, but you have to constantly be surveying to see when it's going to pop up again, because there are a lot of pathways of introduction. Some other examples, we got feathered mosquito fern. We call it Azolla. Its species name is Azolla pinnata. And giant salvinia. These are two that are only in a few places across Florida. Giant salvinia is everywhere in Louisiana and Texas, and we probably have it in 6 places in Florida because we've implemented early detection, rapid response um, really well. And we stay on top of these populations as much as possible and try to drive them to eradication. So, in fact, on January 24th, like Nia said, we are going to try to eradicate this from Lake Jackson because about a month ago it showed up at the Jackson View boat ramp on Highway 27. So, somebody probably went to Louisiana, came back, launched their boat, and it got out from there. Well, the water went down, and now it's just pretty much in the mud. We haven't found in any of the other areas floating along the water, so we just have to get it out of all the brush and bag it all up, and then hopefully we can call it eradicated. We have been successful in several spots in Florida at eradicating this plant, and other ones we're keeping at lowest levels that we can while still striving to eradicate it. Um, and, like I was saying before, a lot of people say, why do you do this? Is this species even going to be a problem? Why don't you wait until you know it's going to be a problem? Why don't you confirm that it's going to be a problem and then put priority or, prioritize going after it or whatnot? Well, um, I wanted to outline this one ecological concept called the lag phase, which basically means any plant that's exotic can become a problem over time. So you got a plant that gets here and it's putting a certain amount of its energy towards defense and a certain amount of its energy towards growth. Well, like I said, when a plant comes to a new area, it doesn't need all that defense. So you're going to have certain plants in a population that actually just naturally put less towards defense. That's usually the first plant to get eaten up. And they don't proliferate within their own population very much because that's the first one the bug's going to. It tastes the best. It's got the fewest chemical defenses in it. Well, over time, in its new population, those ones that put less in defense are going to start growing a little more. They're going to start shading out their peers, and they're going to become the dominant. And they have put more into their growth. And we've seen this in Florida with several species, but one really notable one is Cuban bulrush. Um, this is a plant that arrived the same year that water hyacinth did. And I looked back in our surveys that were started in 1981. They're on so many of our lakes and have always been there, like years before that. And everyone was just like, yeah, it's there. It doesn't really do anything. Year after year after year. Well, 120 years later, boom, huge problem. Now in the panhandle today, we treat more of this plant than we do water hyacinth. It's that bad. And it just hung out for 120 years. Other notable species in Florida are Brazilian pepper, 60 years. It was just chilling before it started really taking off in Florida. And Melaleuca didn't really have bad impacts for 90 years and then became one of our worst invaders. So any exotic plant is a ticking time bomb. And some people might say, well, this has been here for 30 years. It's not going to be bad. You know, it's it's been very well behaved. Well, that doesn't mean that it's always going to be very well behaved. All right, and that's everything, I think. Were there any questions? No, that was really long. Okay, yeah. So for those online, the question was, how do we stay positive? And the short answer is that we don't. It's a very dark line of work. No, I mean, you know, when we eradicate like those EDRR populations and just thinking about the fact that that plant, that could have been the instance that 50 years from now, everyone's like, yeah, this is, what we spend countless hours on this, tens of millions of dollars and blah, blah, blah. And, just thinking that we went ahead and took care of it. We could have said, well, we're going to wait. And then we find it in another lake, and then we find it in another lake. And then we're trying to combat it. And we're like, man, we really missed our opportunity. that's those success stories are really what keep me positive. Also, all the like innovative things that come along. We're doing a lot more with biocontrol. There's a new, not even a new, there's a new technique for using biocontrol for water hyacinth that the biocontrol was released in 2010, didn't really do much, but we're exploring a new technique of how to raise it to be stronger, and it's showing promise. So innovations like that keep me positive at least as well. Did you have one? So stop in Florida, year, like 6 months. Yeah, so the question was, so if management stopped in Florida, would we be buried in like 6 months or a year? And yeah, in some spots, the entire surface of the water body could be covered in water hyacinth in that little amount of time. Um, and yeah, and like you saw in the presentation, even when we get back to work, then we're having to spin our wheels to finally get some traction and get it back down. So yeah, you really can't let off the gas. Yeah. So the question was, with the different haplotypes of the water lettuce, can you see any morphological difference? And I think the short answer is no. The reason why it was even suspected that there were two species in the first place was that Dr. Alan Dre, who's a biocontrol researcher in South Florida, in the 80s, he was doing a biocontrol study of one of the ones they released, and he had this holding pond that was wall to wall water lettuce, put bugs out. They did pretty good. Then he had another one somewhere else, and they didn't do anything hardly. And he was like, "This is weird." And he felt like he could kind of see a difference in morphology. He felt like he could see a difference, and maybe I forget what he says, like coloration, like how waxy the leaves were. Something that he said, like his gut told him that it looked a little different. So we don't have anything yet. I think as they've been looking into this, because they're the ones that started this genetic work. He kind of left the idea for 20 years and he picked it back up after they found some of those seeds in the core sample, but um, probably not is the answer. We'll know more when we run more of them, and maybe we'll be able to find some kind of key to it. But yeah, there's a lot more work to do there. Yeah, so the question was, how are the Brazilian pepper biocontrols doing? I'm not as tapped into that because it's uplands, but I think pretty well. So the limitation with them is they don't spread very well. Which in my mind, I'm like, that's not a problem. Herbicide doesn't spread well. You got to put it out yourself as well. You got to send a human to the plant to put it out. We can do that with bugs. Um, they don't do very well on the mature plants to actually kill them, but new plants they do. So you can come in. That's the whole integrated pest management. Come in, treat the large ones with herbicide, leave some of the biocontrol bugs. They can keep eating that as it dies, and the little young plants they can go kill after that. Is it legal to import aquatic plants to the state? As far as I know, I don't know how the import process works, but um, we don't have like a white list saying like these are cleared for import. Instead, we do a black list on invasive species, which means we wait until it's already everywhere anyway, and it won't matter if another one gets out anyway, then we're going to say you can't bring any more in. So that's something that we really need legislation on, in my opinion. But FWC started to push it a little bit on the animal side, but then FWC is not very good at pushing things like that. I think it would really be up to other groups, especially non-governmental ones, to really push for those types of things. Obviously, on the animal side and the plant side, industry doesn't want that. They want it to be really easy to bring everything in and sell the new thing without having to go through the process of proving that it's not going to be a problem. So the question was, why is muck accumulation especially problematic in aquatic plant management? Um, so when I showed those hydrographs of lakes going way up, flooding, having big flood years and years that it where the lake dried out. In the flood years, any of or a lot of that suspended sediment would go out to the floodplain, and then when the water came down, it would settle out there. And then in the drought years, when it's exposed, it's oxidized. So then a lot of that nutrient cycling would naturally, all that stuff would break down and go back into the system. Well, in a stabilized lake, that organic material that drops to the bottom often goes into an anaerobic state. It's not breaking down. So in the bottom of some lakes, the muck can be here, but the bottom's here. So that's like 2 foot of just, like a mucky, like organic layer. And, that becomes problematic and people don't want to contribute to that. So a lot of people are really passionate about, muck removal and not adding to the muck layer. So the question is, does water hyacinth have a way of, escaping from like a contained area? Fragments, certainly, it's very good at fragmentation. Um, Nia, do you know much about more about its biology? Yeah, yeah, mostly clinical. Yeah, right. Yeah. Yeah, so the comment was that a lot of people say, "Oh, I have water hyacinth. I really want it in my pond. It's contained. It's not going anywhere." It could. It's definitely not as bad as the smaller little floating ferns like Salvinia and Zola and things like that. But like was mentioned in the audience, boats like boat trailers, it gets caught up. I think a lot of that spread is human, but certainly animals could a little tiny fragment, just one bulb could really, um, you know, repopulate. Yeah, and they should be putting frog's bit. There's your look-alike. Yeah. Uh, yeah, go ahead. Yeah, good question. So the question was, how do we coordinate with the Army Corps of Engineers on waterways to manage? So the Army Corps of Engineers, main focus or their stated mission is navigation. They, as y'all know, they do a lot of the like water. water movement and management, like through locks and other systems. Um, but they do a lot of work to keep invasives out of their locks and out of the navigational channels, and they also put a lot of work into habitat management. They also want to see those water bodies healthy, so they have areas that they can work on that are in their jurisdiction. Basically, any navigable waterway would be in their jurisdiction. They do work alongside us in those areas, and they also give us money to do work. So um, if it's if it's floating plants, water lettuce and water hyacinth, there are programs where they give us 100% reimbursement for some water bodies. And for other plants, we do a 50-50 cost share. So we work with them all the time, and they help us out with funding, and we also help out sometimes when their funding's cut if we have some extra and we can send our people into an area to maintain it while they can't work, we try to help them out in that way. Yeah. So the question was, is there any assistance for private ponds for like landowners or anything like that if their ponds are being taken over by invasives? Um, from our program with FWC, the short answer is no. It's written into statute that in order to be eligible for our program, it's got to be a sovereign submerged water body or a fish management area, which is like our wildlife management areas, but they have them for fishing. It's got to be one of those two, or it impacts one of those two. So if it's an early detection rapid response species, we'll go anywhere because that could end up in one of our other water bodies. But if it's water hyacinth that's at some level spread throughout the whole state, then yeah, we're not going into that unless there could be a non-public water body that flows right into our lake and it's more contained than the private one, then we'll say, sure, no problem. We'll go treat that because it's about to come in to ours and spread all over the place and cause us a bigger headache. With fish and wildlife, lake management plan considered the interest of like other fishermen that may be. Yeah, so the question was, does FWC in the management plan have to consider the interest of like duck hunters or fishermen? And I don't think it's written um, into any rules or statutes. In fact, it's written in Florida statute that the legislature prefers a maintenance program and wishes us to keep things in maintenance control. But being the Fish and Wildlife Conservation Commission, we do take all those considerations um, into account when we do our work plans, and we try to work around all of that. In fact, coming up to duck season in areas where there's a lot of duck hunters, we try to get things under super good control so that we can stay out for a little bit before we have to go back in. Anybody else? All right. Well, thank you.